screen! Look at it now, covering the camera!
The deep ocean has always captivated human imagination, from colossal predators like the Megalodon and giant squid to eerie natural phenomena such as glowing Milky Seas and brine pools. Recent explorations have revealed astonishing underwater structures, immense siphonophores, rose-shaped corals, and ancient submerged cities, showing the ocean remains a realm of wonder, danger, and secrets yet to be fully understood.
You can see just how much material is coming out every moment from looking at the smoke.
The colossal squid. The colossal squid is one of the most elusive deep-sea invertebrates ever documented, and its confirmed biological traits startled researchers long before modern imaging technology offered clearer glimpses. The earliest strong evidence came from the recovery of distinctive beaks in 1925, which revealed an animal far larger than any known squid species at the time. These beaks remain among the most reliable anatomical indicators of the creature's true scale, allowing scientists to estimate its maximum size even without complete specimens. Based on these recovered beaks, researchers have calculated that fully grown individuals can reach approximately 30 to 33 feet in total length and may weigh as much as 1,500 pounds, although the few specimens caught or photographed have weighed closer to 500 kilograms. Such dimensions make it one of the largest and heaviest invertebrates on Earth, surpassing many marine animals in sheer bulk. Sightings and specimen recoveries are exceptionally rare because the colossal squid inhabits the deep, cold waters of the Antarctic region. These frigid depths, often reaching around 7,200 feet below the surface, are nearly inaccessible to humans, limiting opportunities for observation. Low temperatures, perpetual darkness, and unique deep-sea ecological conditions allow this species to remain hidden, contributing to its enigmatic reputation. A notable anatomical feature is the presence of swiveling, three-pointed hooks on its tentacles. These hooks are unique among cephalopods and provide the squid with an effective grasping mechanism, enabling it to secure fast-moving prey in an environment where encounters may be brief and energy conservation is essential. Did you know great whites eat each other? A shocking tag reveal exposes deadly secrets of oceanic apex predators. The great white shark cannibalism case. The case involving a tagged great white shark that vanished unexpectedly remains one of the most striking examples of intraspecies predation recorded through modern tracking technology. The event began when a 9-foot great white, previously fitted with a monitoring device, suddenly stopped transmitting. Days later, the detached tracking tag washed ashore under unusual circumstances. When researchers examined the stored data, they found clear evidence of an abrupt and dramatic temperature spike, far higher than normal seawater conditions, immediately followed by a rapid, steep descent to depths approaching 2,000 feet. These readings strongly suggested that the device had been swallowed and that it had continued recording from inside the digestive tract of a much larger animal. Detailed scientific analysis of the temperature profile, depth changes, and movement patterns indicated that the predator was not an unknown species, but another, significantly larger, great white shark. Estimates placed the larger shark at roughly 16 feet in length, weighing close to 2 tons. This conclusion offered rare and direct documentation of cannibalistic behavior among adult great whites, a species typically considered to be apex predators with minimal threat from other animals. Great white sharks generally avoid one another except in contexts involving competition or feeding opportunities. Research shows that interactions can escalate when two individuals occupy overlapping hunting grounds or when dominance must be established. Although cannibalism among adults is not common, it is a recognized behavior under certain environmental or competitive pressures. Cases like this confirm that large great whites may attack and consume smaller individuals when the opportunity presents itself. Are ancient humans behind this mysterious underwater structure, or did nature craft an impossible geometry in the ocean depths? The Yonaguni Monument. The Yonaguni Monument, discovered off the coast of Japan in 1986, remains one of the most debated underwater structures in modern marine geology. The formation is visually striking, featuring sharp angles, flat surfaces, and stepped terraces that immediately capture the attention of researchers and divers alike. It consists of massive sandstone blocks shaped into platforms, edges, and geometric planes, which in some ways resemble architectural construction. The monument's appearance has fueled both scientific investigation and popular speculation regarding its origins. Researchers have long debated whether the formation is entirely natural or partially shaped by early human modification. Many geologists classify the structure as a product of natural sandstone erosion, noting that sandstone tends to fracture along horizontal bedding planes and vertical joints. These natural processes can produce remarkably clean angles and flat surfaces that may appear artificial to the observer. As a result, much of the monument's geometry can be explained by natural geological forces, including tectonic activity, sedimentary layering, and erosion from ocean currents and wave action over thousands of years. Despite these natural explanations, certain features continue to intrigue scientists who consider the possibility of human involvement. The site contains flat walls, pillar-like shapes, and formations resembling staircases, leading some researchers, notably Professor Masaki Kimura, to propose limited human modification. Comparisons have been made to columns, animal carvings, and Lego-like assemblages, reflecting the debate over whether surface markings are the result of deliberate shaping or simply natural abrasion. Although the monument has occasionally been linked in popular literature to ancient civilizations or lost continents such as Mu, there is no empirical evidence supporting such claims. Current research suggests that tectonic uplift, combined with wave-cut processes, likely shaped most of the visible features. High-resolution 3D seafloor scanning shows fracture patterns consistent with sedimentary bedding, although localized smoothing in certain areas may indicate human tool use on a small scale. The ongoing discussion highlights how the Yonaguni Monument remains a compelling intersection of natural geology and the possibility of early human activity, making it a unique subject for continued study. Life thriving without sunlight? Towering chimneys spew superheated fluids, rewriting the rules of survival on our planet. Hydrothermal vent black smokers. The hydrothermal vents, known as black smokers, were first observed in 1977 near the Galapagos Rift, revolutionizing scientific understanding of deep ocean ecosystems. These vents form tall, chimney-like structures, some reaching nearly 60 meters in height. Built from minerals that precipitate when superheated fluids meet frigid seawater. The recorded temperature of these fluids can approach 400 degrees Celsius, creating conditions intense enough to cook a steak. Yet these extreme environments support remarkably dense and diverse biological communities. The vents release mineral-rich plumes that appear as dense black clouds due to high sulfide content. Despite the surrounding darkness, cold, and high pressure that render the environment inhospitable to most life, specialized organisms thrive. Species such as giant tube worms, vent shrimp, and deep-sea snails rely on chemosynthetic bacteria, which convert chemicals from the vent fluids into usable energy. This process is entirely independent of photosynthesis, demonstrating that ecosystems can exist without sunlight and providing crucial insights into alternative pathways for sustaining life. The towering chimneys and their surrounding environment create an otherworldly landscape that emphasizes the uniqueness of these habitats. Beyond their visual impact, Black smokers are scientifically significant because they suggest that life can adapt to extreme chemical and thermal gradients. Modern research indicates that environments similar to hydrothermal vents on early Earth may have hosted some of the planet's first metabolic systems. Chemical gradients within vent walls resemble proto-cell compartments, offering a natural laboratory to study the origin of life and the chemical processes that could have supported it. These discoveries have implications beyond Earth. By demonstrating that life can flourish independently of sunlight, hydrothermal vent ecosystems inform theories about the potential for life on other planetary bodies, particularly moons with subsurface oceans, such as Europa or Enceladus. A Bronze Age city rests beneath the waves. How did ancient streets vanish without a catastrophic event? The Submerged city, near Pavlopetri. The underwater settlement off southern Greece, known as Pavlopetri, is one of the most well-preserved Bronze Age sites in the world. Initially mapped in 2009 using high-resolution 3D modeling, researchers revealed an extensive layout featuring streets, individual rooms, and an organized harbor, confirming the site's status as a sizable and sophisticated submerged settlement. The detailed mapping allowed archaeologists to study the city's urban planning and infrastructure, providing insight into the lives of its ancient inhabitants. Spanning approximately 9,000 square meters, Pavlopetri is a verified prehistoric port town dating back to around 3,500 BCE. Unlike speculative claims about underwater lost cities, its existence is well documented through physical evidence. The settlement exhibits well-planned structures and a defensive arrangement, reflecting careful urban design and social organization. Its eventual submergence was not sudden or catastrophic, but rather the result of gradual subsidence combined with rising sea levels over millennia. This slow process contrasts sharply with mythical narratives of instant disappearance, providing a clear example of natural geological change over time. Archaeologists have uncovered extensive artifacts at the site, including pottery, stone structures, and evidence of trade activity. These findings indicate that Pavlopetri was once a vibrant and bustling center, involved in extensive regional commerce. The combination of architectural remains and material culture provides a detailed picture of daily life, trade networks, and the town's social structure. Recent sediment analysis has revealed multiple phases of shoreline retreat, suggesting that Pavlopetri was repeatedly affected by earthquakes common in the Hellenic Arc. These seismic events contributed to uneven sinking across the settlement, further influencing the gradual submergence of its structures. The site thus offers a unique window into both ancient human activity and the long-term effects of natural environmental processes on coastal settlements. Its preservation underwater allows researchers to study Bronze Age urban planning in a way few other sites worldwide can match. Oceans glowing like ghostly lanterns. What triggers these massive bioluminescent displays that baffle even modern science? The Milky Seas phenomenon. Reports of Milky Seas appear throughout maritime history, describing vast stretches of ocean glowing with a faint white or blue light. Scientific research attributes this phenomenon to bioluminescent bacteria, specifically organisms capable of producing continuous light. Modern studies confirm that the glow is caused by luminous bacteria such as Vibrio harvei, which multiply in large concentrations and create an even, sheet-like radiance. Observations indicate that the glow is a real, measurable marine event rather than a myth or exaggeration, matching centuries of sailors' accounts. Mariners moving through these glowing waters often described the sea as if illuminated from within, an eerie and otherworldly experience. Scientific documentation now supports these observations. Satellite detections in 2005 and again in 2021 captured massive glowing patches, one of which covered nearly 100,000 square kilometers. These large-scale luminous events confirm that Milky Seas are not isolated or anecdotal, but can occur over enormous areas, producing a continuous radiance that can be seen even from space. Despite understanding the organisms responsible, the environmental triggers that cause such synchronized, large-scale bioluminescence remain unclear. Recent research suggests that calm seas, abundant organic material, and specific microbial quorum sensing thresholds may initiate these vast light displays. Conditions must be just right for the bacteria to produce light at this scale, which is why Milky Seas are rare and unpredictable. Advances in satellite ocean color technology now allow scientists to detect and monitor these events over time, offering the possibility of predicting or studying future occurrences more systematically. While the exact mechanisms behind these massive displays of light remain a mystery, the phenomenon provides a striking example of nature's capacity to produce awe-inspiring effects on a grand scale. Milky Seas continue to intrigue oceanographers, sailors, and the general public alike, bridging centuries of human observation with modern scientific understanding. A bizarre circular formation on the seafloor sparks speculation, ancient UFO or nature's uncanny trick. The Baltic Sea anomaly. The Baltic Sea anomaly was discovered in 2011 by divers performing a detailed seafloor scan in the Baltic Sea. The formation immediately drew attention due to its round, flat, and distinctly patterned structure, which some observers compared to fictional spacecraft shapes. While these visual impressions captured public imagination, scientific evaluations have offered more grounded explanations. Geological surveys indicate that the anomaly is likely a natural glacial rock deposit, formed during periods of ice movement across the region and shaped by glacial dynamics over thousands of years. Early low-resolution sonar images contributed to the mystery, producing grainy visuals that suggested artificial patterns. These images created a misleading impression of manufactured design, though closer examination reveals the features to be consistent with natural processes. Observed ridges, depressions, and steps correspond to the effects of glacial scouring, moraine accumulation, and post-glacial rock fracturing rather than human construction. The surrounding sediment and rock fragments match local geological materials, reinforcing the interpretation that the anomaly is entirely natural. Despite the natural explanation, the anomaly's unusual symmetry and geometric appearance distinguish it from typical glacial boulders, making it a subject of ongoing interest. Petrographic analysis shows that the formation consists of sandstone, siltstone, and fractured bedrock, commonly found in glacial deposits. The object's ledges and terraces align with jointed rock fractured under the immense pressure of past ice sheets, creating straight edges and flat surfaces that appear striking from certain angles. The Baltic Sea anomaly highlights how nature can produce formations that seem artificial at first glance. Its unique geometry and the interplay of geological processes such as glacial erosion, sediment deposition, and rock fracturing combine to create a structure that continues to intrigue scientists and divers alike. While no evidence supports an artificial origin, the formation serves as a compelling example of how natural forces can create patterns that challenge perception and stimulate curiosity. Deadly underwater lakes suffocate anything that touches them. Could these toxic brine pools reveal life on alien worlds? The Jacuzzi of Despair. The Jacuzzi of Despair is a brine pool discovered in the Gulf of Mexico around 2015. These brine pools form when dense, salt-saturated water becomes trapped in depressions on the sea floor, creating a distinct, isolated body of water. The pool is characterized by extremely high salinity, as well as elevated levels of methane and hydrogen sulfide, creating a toxic environment in which fish, crustaceans, and other marine organisms perish almost instantly upon contact. Measurements taken by remote-operated vehicles confirm that the pool is roughly 12 feet deep and about 32 feet across. Its unusual temperature ranges from approximately 7.8 degrees Celsius to nearly 19 degrees Celsius, warmer than the surrounding waters. This temperature difference contributes to the pool's layered, lake-like appearance and helps maintain a stable boundary, effectively forming an underwater shoreline that separates the dense brine from the surrounding ocean. Marine organisms that fall into the pool cannot escape due to the brine's density, which is several times higher than that of surrounding seawater. As a result, the pool is often surrounded by the remains of trapped sea life, providing a stark visual indicator of the pool's lethal properties. Researchers are particularly interested in the microbial communities living along the edges of the pool. These bacteria thrive in conditions that are toxic to most other life forms, making them important models for understanding extremophile survival. Modern genetic studies reveal that these microbes possess specialized sulfur reduction pathways, allowing them to metabolize chemicals such as hydrogen sulfide for energy. The Jacuzzi of despair serves as a valuable natural laboratory for astrobiology, offering insights into how life might survive in extreme environments beyond Earth. Its extreme conditions resemble those hypothesized for extraterrestrial oceans, such as beneath the ice of moons like Europa, providing a unique opportunity to study life's adaptability in high-salinity, chemically harsh ecosystems. A mysterious deep-sea moan echoes from Antarctica. What's creating this haunting sound beneath the ice? The sound called Julia. The sound known as Julia, recorded by NOAA in 1999, remains one of the most enigmatic acoustic events in the world's oceans. It was captured as a loud, eerie noise lasting approximately 15 seconds, which immediately attracted both scientific and public interest due to its unusual characteristics. Scientists have largely focused on natural explanations, with the leading theory being that Julia resulted from an iceberg colliding with the Antarctic landmass. The event occurred in a region known for intense ice activity, including shifting ice shelves and grounding of massive icebergs, making this explanation highly plausible. The recording of Julia exhibited an unusually high amplitude, allowing the sound to propagate across a vast oceanic distance. Data from NOAA's hydrophone arrays confirmed that the sound traveled far, consistent with the behavior of large-scale ice events under extreme polar conditions. Researchers proposed several possible mechanisms for the sound, including iceberg grounding or fracturing, both of which are common in the turbulent ice environment of Antarctica. Speculation about the source of Julia has occasionally extended into more imaginative territory, with some suggesting the involvement of enormous unknown creatures. However, there is no evidence to support such claims, and the frequency profile of the sound matches what would be expected from large ice-related events, rather than biological sources. Reports of satellite images allegedly showing large shadows near the time of the sound have circulated but were never substantiated. No official imagery has confirmed the presence of any anomalous mass moving through the waters. Since 2000s, similar icequake signatures have been recorded frequently, particularly during major iceberg calving events. The frequency patterns of these events closely match Julia's waveform, further strengthening the hypothesis that the sound was generated by ice activity. Overall, Julia remains a remarkable example of how natural processes in Antarctica can produce powerful, far-reaching acoustic phenomena in the ocean. Frozen fingers descend from the ice, trapping creatures instantly. Antarctica's deadly brinicles defy imagination. Brinicles, the frozen fingers of death, Brinicles, often referred to as frozen fingers of death, form when dense, supercooled brine drains from forming sea ice and sinks rapidly into the sea water below. As the descending brine moves downward, it freezes the surrounding water, creating a hollow, tube-like icicle that can extend several meters toward the seabed. These striking structures are both visually dramatic and ecologically significant, illustrating the complex interactions between ice, salt, and seawater in polar environments. Their appearance is truly otherworldly. Observations in Antarctic regions have shown that brinicles can trap slow-moving organisms such as sea stars or urchins, freezing them in place if they cannot escape the downward path of the icy column. This lethal mechanism underscores the extreme conditions under which brinicles form and the fragile nature of life in polar waters. Brinicles occur only under very specific conditions: calm waters, stable sea ice formation, and freezing brine channels within the ice sheet. Their rarity and the difficulty of accessing their remote habitats have historically made them challenging to study. Although anecdotal reports existed for decades, brinicles were filmed clearly for the first time in 2011, providing scientists with a direct visual record of their formation process. The development of a brinicle is slow and deliberate. As brine channels contract, the dense, supercooled fluid funnels downward, crystallizing the surrounding seawater and forming a descending column of ice. This growth pattern can continue until the brinicle reaches the seabed, completing the vertical icy conduit. Modern oceanographers employ high-resolution time-lapse cameras to study brinicle formation and growth patterns, revealing insights into ice chemistry, brine dynamics, and microhabitat creation. Beyond their immediate ecological impact, brinicles also provide models for understanding early Earth ice environments and offer clues for the study of cryogenic oceans on icy moons, highlighting the relevance of these structures for planetary science and astrobiology research. Prehistoric oceans once hosted 59-foot killing machines. How did these apex predators dominate before vanishing forever? Megalodon fossil evidence. The megalodon was one of the most formidable predators to ever inhabit the world's oceans. This prehistoric shark reached lengths of up to 59 feet, with an estimated mass of approximately 59 metric tons, making it vastly larger than any living shark species. Its enormous teeth, some measuring up to 7 inches, are among the few physical remains that survive today, as cartilage skeletons rarely fossilize. These teeth have been central to reconstructing the animal's size, feeding behavior, and predatory strategies, allowing scientists to infer how megalodons dominated ancient marine ecosystems. No complete skeletons of megalodon have ever been found, which aligns with the scientific record. Fossil evidence primarily consists of teeth, vertebral centra, and occasional jaw fragments, yet these remains are sufficient to indicate that megalodons inhabited warm, temperate seas across the globe. Fossil distributions suggest they were apex predators capable of hunting large marine mammals, including whales, and were widespread across oceans during the Miocene and Pliocene epochs. Most scientists agree that megalodons went extinct around 3.6 million years ago, a conclusion strongly supported by fossil layer dating. While occasional fringe speculation suggests survival into modern times, no credible evidence exists to support these claims. Comparisons to species like the coelacanth or the megamouth shark highlight the ocean's capacity for surprises, but the fossil record firmly places megalodon's extinction millions of years before any modern sightings. A 2023 isotopic study provided additional insights, indicating that megalodons may have had a partially warm-blooded metabolism. This adaptation would have allowed them to maintain high activity levels across vast regions, but also increased their energy requirements. Combined with competition from emerging species such as early great white sharks and declines in marine mammal populations, these metabolic demands likely contributed to their eventual extinction. The Megalodon remains a symbol of prehistoric oceanic power and continues to fascinate scientists and the public alike. 4 submarines vanished without a trace. What truly happened beneath the ocean's crushing depths? The lost submarines of 1968. The tragic events of 1968 marked the deadliest year for submarines since World War II. 4 vessels from different nations disappeared separately: the USS Scorpion, INS Dakar, Minerve, and K-129. The scale of loss, 318 people, and the international scope of the incidents, which occurred across different oceans, underscores the magnitude of the tragedies. These disappearances were mysterious and difficult to explain due to limited accessible information and classified military records. The portrayal aligns with the historical challenge of determining submarine failures, as many operational details remain restricted. Theories ranged from mechanical failures to accidental flooding, or even unverified suggestions of hostile involvement. These possibilities reflect real technical concerns of Cold War-era submarines, including battery explosions, torpedo malfunctions, and hull integrity failures. Extensive search efforts did not provide clear answers for some of the vessels, reinforcing the uncertainty surrounding several of these tragedies. Each submarine's loss occurred under different circumstances, which prevented researchers from identifying a single shared cause. Modern declassified assessments indicate the USS Scorpion likely suffered a battery or torpedo-related internal failure, while INS Dakar probably exceeded its crush depth during a descent. K-129's sinking is believed to involve a catastrophic mechanical malfunction. Minerve likely encountered instability exacerbated by rough weather. A 150-meter-long spiral drifts through Australian waters. Could this be the largest animal colony ever discovered? The giant siphonophore of Ningaloo. The discovery of the giant siphonophore near the Ningaloo Canyons in Western Australia in 2020 was one of the most surprising deep-sea observations ever recorded. Researchers operating a remotely controlled vehicle, ROV, from the Schmidt Ocean Institute encountered a 150-meter-long siphonophore, arranged in a spiraling formation, making it possibly the largest animal colony ever documented. Siphonophores are colonial organisms composed of thousands of genetically identical units called zooids, each specialized for specific functions such as feeding, stinging, movement, and reproduction. What astonished scientists most was not only the siphonophore's immense length, but also its intact, wide spiral structure, which is rarely preserved in deep water environments. Such formations suggest stable water conditions, minimal disturbance, and low predation, allowing the organism to maintain a remarkably complex geometric shape. Observations revealed that each zooid coordinates seamlessly, creating a functional colony that operates almost like a single organism. The Ningaloo Canyons expedition also documented dozens of previously unknown species, highlighting how little of the ocean's deep benthic regions have been explored. The size of this siphonophore demonstrates that deep-sea ecosystems can sustain enormous organisms using minimal energy, relying primarily on drifting and stinging small prey. This finding provided invaluable insight into siphonophore growth patterns, energy distribution among zooids, and overall colony behavior. Its length and structure far exceeded previous scientific models, suggesting that some deep-sea organisms can achieve unprecedented biological scale. Subsequent ecological modeling indicates that the organism may extend even longer when fully unfurled, and its morphology resembles the rare Apolemia genus, confirming the deep ocean's capacity to host extraordinarily massive, yet delicate, living structures. Titanic icebergs carved miles-long scars into the seafloor. What do these hidden marks reveal about past glacial giants? 2019 Greenland Mega Iceberg Gouges. In 2019, oceanographic surveys off Greenland's coast revealed massive seafloor gouges carved by ancient icebergs, astonishing scientists with their sheer scale, depth, and length, providing new insights into past glacial movements and the immense forces exerted by these colossal ice masses. The gouges, some stretching several miles and plunging over 25 meters deep, were created when colossal icebergs, grounded during past glacial periods, scraped across the ocean floor. These iceberg scars indicate that ancient icebergs were far thicker and more massive than previously believed, some weighing billions of tons. Researchers used high-resolution multi-beam sonar to map these formations, revealing parallel grooves consistent with large ice structures being pushed by ocean currents or glacial flow. The unexpected depth of the gouges challenges earlier models of iceberg buoyancy and thickness in the late Pleistocene, suggesting icebergs extended much deeper into the water column during past climatic cycles. The discovery also provides new insights into Greenland's historical ice sheet behavior, revealing fluctuations in calving intensity and iceberg grounding patterns. These gouges help reconstruct past sea levels and ocean temperatures, contributing to more accurate forecasting of modern ice sheet retreat. Scientists now use these gouges to refine models predicting iceberg drift under warming conditions, providing clues to future seafloor disturbance patterns and sediment transport. Strange rose-shaped corals bloom in the deep sea. How did these unknown giants escape scientists until now? 2023 Rose-shaped deep-sea corals. In 2023, marine explorations near the Galapagos Islands discovered extraordinary rose-shaped corals forming intricate flower-like structures several meters wide, previously unknown to science, revealing the deep sea's ability to host stunning, complex, and previously unobserved marine life forms. These newly documented corals form broad, circular plates several feet across. Their layered, curved rims create formations reminiscent of petals, earning them their descriptive name. They belong to deep-sea coral communities, thriving at depths where sunlight cannot penetrate, relying on cold, nutrient-rich currents. The discovery astonished scientists because many regions of deep-sea coral habitat were previously believed to be damaged by warming waters and changing ocean chemistry. Instead, these rose-shaped colonies were thriving, suggesting that some deep ecosystems remain resilient. ROV footage revealed extensive coral gardens covering steep underwater slopes, supporting diverse fish and invertebrate communities. These corals are slow-growing and centuries old, providing valuable records of historical ocean conditions. Genetic sequencing indicates some of these corals belong to previously undescribed species, emphasizing how little of the Galapagos deep sea has been explored. Their survival suggests stable deep water conditions that could offer refuge amid global ocean changes. From colossal predators and glowing Milky Seas to submerged cities and rose-shaped corals, the deep ocean teems with wonders. Will science ever uncover all its secrets, or will mysteries endure forever? Share your thoughts in the comments below.